Welcome to the Slumber Lab, where science meets the stillness of sleep and curiosity drifts gently into the quantum realm. I'm so grateful you've chosen to spend this quiet hour with me. Before we begin our gentle voyage into the quantum world, I'd love to know where you are right now. Are you tucked into bed with the soft glow of city lights beyond your window? Perhaps you're curled up in a cozy chair as evening settles around you. Or maybe you're on the other side of the world where dawn is just beginning to whisper its arrival. Wherever you are, whatever time it is in your corner of the universe, you're exactly where you need to be for this dreamy exploration of quantum reality. If you find these sleepy scientific journeys soothing, I'd be ever so grateful if you gave this video a gentle like and perhaps subscribe to join our community of curious minds who love learning while they unwind. It helps more sleepy scientists like yourself find their way to this calm corner of the internet. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll drift off knowing something extraordinary about the hidden workings of our universe. That seems like a fair trade, doesn't it? So settle in, slow your breathing, and let's begin our quiet journey into the strange, beautiful, and utterly bewildering world of quantum particles. Because tonight, we're not just observing the quantum realm from the outside, we're stepping inside the mind of a particle itself, experiencing reality as it does, in all its uncertain, shimmering, probability-filled glory. What would it feel like to be a quantum particle? It's a question that sounds almost whimsical, like asking what it's like to be a rainbow or a whisper. But in the quantum world, this isn't just poetry, it's physics. And the answer is far stranger and more wonderful than you might imagine. To understand what it means to be inside the mind of a quantum particle, we need to start with something beautifully simple yet profoundly mysterious: the nature of quantum reality itself. You see, quantum particles don't behave like the objects we're familiar with in our everyday world. They don't have definite positions or velocities in the way a marble or a butterfly does. Instead, they exist in what physicists call superposition, a state where they can be in multiple places, multiple states, multiple realities all at once. Imagine for a moment that you could be simultaneously reading this in your bedroom, in a library, and on a park bench, all at the same time. Not metaphorically, but literally, existing in all these places until someone looks for you and finds you in just one of them. This is the everyday reality for quantum particles, and it's the first glimpse into their strange inner world. When we talk about the mind of a quantum particle, we're really talking about the fundamental nature of information and reality at the smallest scales. Every quantum particle carries information about its state, its properties, its relationships with other particles. But here's the twist. This information isn't stored like data on a hard drive. It's more like a symphony of possibilities, a harmony of potential outcomes that exist simultaneously until the moment of observation collapses them into a single, definite reality. The quantum world operates on principles that seem to defy our everyday intuition. Take the principle of complementarity, for instance. A quantum particle can be described as both a wave and a particle, but never both at the same time. It's as if the particle has two different personalities, two different ways of being, and which one we encounter depends entirely on how we choose to observe it. When we set up an experiment to detect its wave-like properties, it behaves like a wave. When we design an experiment to catch it being particle-like, it obliges by being a particle. This isn't just a limitation of our measuring tools, it's a fundamental feature of quantum reality. The particle doesn't have a secret, hidden state that we're failing to detect. Rather, it genuinely exists in this state of multiplicity until the moment of measurement forces it to choose just one way of being. Now let's drift deeper into this quantum mindscape. Imagine you're a photon, a particle of light, about to embark on a journey through space. But unlike a traveler in our familiar world, you don't have a predetermined path. Instead, you exist as a cloud of probability, a ghostly presence that simultaneously explores every possible route to your destination. In the quantum realm, this isn't metaphorical, it's literal. The photon doesn't take one path. It takes all paths. It travels through empty space, bounces off mirrors, refracts through glass, and curves around obstacles all at the same time. Each path contributes to the particle's overall state, creating an interference pattern of possibilities that shapes its final destination. This phenomenon, known as quantum superposition, is perhaps the most alien aspect of quantum reality from our everyday perspective. We're used to things being in definite states at definite times. A coin is either heads or tails. A door is either open or closed. You're either awake or asleep. But quantum particles exist in a liminal space between all possibilities, embodying the very essence of uncertainty. The mind of a quantum particle, if we can call it that, is a mind that holds contradictions without conflict. It's simultaneously here and there, moving and still, spinning clockwise and counterclockwise. It's a consciousness, if we dare use that word, that experiences reality, not as a single, linear narrative, but as a symphony of parallel stories, all equally real until the moment of observation selects just one to become manifest. This brings us to one of the most beautiful and mysterious aspects of quantum mechanics, the role of the observer. In our everyday world, we assume that things exist independently of whether we're looking at them or not. The moon doesn't disappear when we close our eyes, and our coffee cup doesn't cease to exist when we leave the room. But in the quantum world, the act of observation plays a fundamental role in determining reality. When a quantum particle is observed, measured, or detected, its wave function, what physicists call the mathematical description of all its possible states, collapses into a single, definite outcome. It's as if the particle, faced with the attention of an observer, suddenly has to make up its mind about what it wants to be. This isn't because our measuring instruments are clumsy or intrusive, though they often are. It's because the very act of gaining information about a quantum system necessarily disturbs it. To observe a particle, we have to interact with it in some way, perhaps by bouncing a photon off it to see where it is. But that interaction changes the particle's state, forcing it to collapse from its superposition of possibilities into a single, definite reality. From the particle's perspective, if we can imagine such a thing, this moment of observation might feel like suddenly snapping into focus, like a dream crystallizing into waking reality. One moment, it exists in a fluid state of infinite potential. The next, it's locked into a specific position, momentum, or spin state. But here's where things get even more wonderfully strange. The quantum world is not just about individual particles floating in isolation. It's about relationships, connections, and what physicists call entanglement. When two quantum particles become entangled, they form a kind of cosmic partnership that transcends space and time. Imagine two particles, created together in a quantum process, flying apart to opposite ends of the universe. When one particle is observed and its wave function collapses into a definite state, its entangled partner instantly adopts the corresponding state, no matter how far away it is. This isn't communication in any conventional sense. No signal travels between the particles. No information is transmitted at the speed of light or any other speed. Instead, the two particles share a kind of quantum consciousness, a single, unified state that exists beyond the boundaries of space and time. From inside the mind of an entangled particle, this might feel like being part of a larger self, a distributed consciousness that spans the cosmos. The particle doesn't exist as an isolated individual, but as part of a quantum collective, sharing its reality with its entangled partners, no matter how far apart they might be. This interconnectedness extends beyond just pairs of particles. In principle, any quantum system can become entangled with any other, creating vast networks of quantum correlation that bind the universe together in ways we're only beginning to understand. Some physicists speculate that the entire universe might be one giant, entangled quantum system, with every particle connected to every other particle in a web of quantum relationships that underlies all of reality. As we drift deeper into this quantum dreamscape, we encounter another strange feature of the particle's inner world, the uncertainty principle. Formulated by Werner Heisenberg, this principle states that there are fundamental limits to how precisely we can know certain pairs of properties of a quantum particle simultaneously. The more precisely we know a particle's position, the less precisely we can know its momentum, and vice versa. But this isn't just a limitation of our measuring instruments. It's a feature of reality itself. From the particle's perspective, it doesn't have a definite position and momentum at the same time. These properties exist in a state of fundamental fuzziness, a quantum blur that's not due to our ignorance, but to the very nature of quantum reality. Imagine trying to pinpoint your exact location and your exact speed of movement at the same moment. In the quantum world, this isn't just difficult, it's impossible in principle. The particle exists in a state where these properties are inherently uncertain, not because we don't know them, but because they don't have definite values to be known. This uncertainty isn't a bug in the quantum system, it's a feature. It's what allows quantum particles to tunnel through barriers they shouldn't be able to cross, to exist in multiple states simultaneously, and to participate in the strange quantum phenomena that make our universe possible. The mind of a quantum particle, if we can stretch our imagination that far, might experience this uncertainty not as confusion or ignorance, but as a kind of creative freedom. Unbounded by the rigid certainties of classical physics, the particle exists in a space of infinite potential, where every moment offers a new array of possibilities. This brings us to one of the most practical and revolutionary applications of quantum mechanics: quantum computing. In classical computing, information is stored in bits that are either 0 or 1, on or off. But quantum computers use quantum bits, or qubits, that can exist in superposition states of both 0 and 1 simultaneously. A quantum computer with just 300 qubits could, in principle, perform calculations on more possible states than there are atoms in the observable universe. This isn't because the computer is fast, it's because it's exploring multiple parallel realities simultaneously, harnessing the strange properties of quantum superposition to solve problems that would take classical computers longer than the age of the universe to complete. From the perspective of a qubit in a quantum computer, processing information might feel like living multiple lives simultaneously, exploring every possible solution to a problem at once, and then crystallizing into the correct answer when observed. It's computation not as a linear sequence of steps, but as a quantum symphony of parallel possibilities. As we continue our gentle exploration of the quantum mind, we encounter the phenomenon of quantum decoherence. This is the process by which quantum systems lose their quantum properties and begin to behave more like classical objects. It happens when a quantum system interacts with its environment, causing its delicate superposition states to collapse into definite classical states. Decoherence is why we don't see quantum superposition in our everyday world. The larger and more complex a system becomes, the more it interacts with its environment, and the faster it loses its quantum properties. A single photon can maintain its quantum state for a long time, but a cat or a person interacts with so many other particles that their quantum properties decohere almost instantly. From the particle's perspective, decoherence might feel like a gradual awakening from a dream of infinite possibilities into the more constrained reality of classical physics. It's the moment when the particle's quantum consciousness, distributed across multiple states, gradually focuses into a single, definite reality. But even as decoherence sets in, the quantum world doesn't disappear entirely. It retreats to smaller and smaller scales, to the microscopic realm where individual atoms and molecules still dance to quantum rules. And it's at these scales that life itself harnesses quantum mechanics in ways we're only beginning to understand. Photosynthesis, the process by which plants convert sunlight into chemical energy, appears to use quantum coherence to achieve its remarkable efficiency. When light strikes a leaf, the energy doesn't just randomly bounce around until it finds the reaction center. Instead, it seems to explore multiple pathways simultaneously, using quantum superposition to find the most efficient route to where it needs to go. Even more intriguingly, some researchers suspect that consciousness itself might have quantum mechanical underpinnings. While this idea remains highly speculative and controversial, it raises the fascinating possibility that our own minds might operate, at least in part, according to quantum principles. If this is true, then the boundary between the observer and the observed, between the classical world of everyday experience and the quantum realm of infinite possibilities, might be far more porous than we imagine. We might not just be observing quantum particles from the outside. We might be quantum processes ourselves, experiencing reality from within the very quantum mechanical framework we're trying to understand. As we near the end of our journey into the quantum mind, let's take a moment to appreciate the profound strangeness and beauty of what we've discovered. The quantum world is not just a collection of bizarre phenomena that happen to occur at microscopic scales. It's the fundamental layer of reality, the deep structure upon which everything else is built. From the perspective of a quantum particle, reality is not a fixed, predetermined stage upon which events unfold. It's a fluid, dynamic process of constant becoming, where possibilities crystallize into actualities only through the act of observation or interaction. The particle exists not as a thing, but as a process, a pattern of relationships and potentials that dances between being and non-being. This quantum view of reality challenges our deepest assumptions about the nature of existence. It suggests that the universe is not a machine, grinding through predetermined motions, but something more like a cosmic improvisation, where the future emerges from the interplay of possibility and actuality, observer and observed, mind and matter. Perhaps most remarkably, quantum mechanics reveals that the universe is far more interconnected than our everyday experience suggests. Through quantum entanglement, particles separated by vast distances share a common reality. Through quantum superposition, single particles explore multiple realities simultaneously. Through quantum decoherence, the microscopic world of infinite possibilities gives rise to the macroscopic world of definite outcomes. The mind of a quantum particle, if we can speak of such a thing, is a mind that experiences reality as a symphony of possibilities, a dance of probabilities, a web of relationships that transcends the boundaries of space and time. It's a consciousness, if we dare call it that exists not in opposition to uncertainty, but in harmony with it. finding freedom and creativity in the very indeterminacy that makes our universe possible. As you drift off to sleep tonight, perhaps you might imagine yourself as a quantum particle, existing in a state of peaceful superposition, exploring multiple dreams simultaneously until the gentle observation of morning consciousness collapses your sleep state into the single, definite reality of a new day. The quantum world reminds us that reality is far stranger, far more beautiful, and far more interconnected than our everyday experience suggests. At the smallest scales, the universe is not a collection of separate objects, but a unified field of possibilities, constantly creating itself anew through the mysterious process of quantum mechanical becoming. And in that mystery, in that endless dance of possibility and actuality, we find not just the secret of the quantum world, but perhaps a glimpse into the deepest nature of existence itself. The mind of a quantum particle is, in the end, a mirror of the cosmic mind that dreams all realities into being, one quantum observation at a time. So, rest well, knowing that you are part of this grand quantum tapestry, connected to every other particle in the universe through invisible threads of quantum entanglement, existing in your own superposition of sleeping and waking until the gentle measurement of consciousness determines which reality you'll inhabit when you open your eyes again. The quantum realm is always there, humming quietly beneath the surface of everyday experience, reminding us that the universe is far more magical, far more mysterious, and far more wonderful than we ever dared imagine. And tonight, as you slip into dreams, you carry with you the secret knowledge of what it means to exist inside the mind of a quantum particle, dancing between possibility and reality in the endless quantum waltz of existence. Sweet dreams, fellow quantum travelers. Welcome back to the Slumber Lab, where consciousness gently meets the quantum realm and where the smallest particles in the universe hold the most extraordinary secrets. You've journeyed with us through the strange landscape of superposition and wave-particle duality, discovering how quantum particles exist in multiple states simultaneously until the very moment we observe them. We've explored how these tiny entities seem to dance between possibilities, collapsing into reality only when consciousness arrives to witness their performance. But now, dear traveler, we venture deeper into the quantum mystery. We're about to discover something that challenges not just our understanding of physics, but our very perception of what it means to exist in this universe. Tonight, we explore the phenomenon that Einstein himself called spooky action at a distance, quantum entanglement, and we'll uncover how it reveals a universe far more interconnected than our classical minds could ever imagine. If you're settling in for the night, perhaps with the gentle hum of distant traffic or the soft whisper of wind through trees, know that you're about to embark on a journey that will show you how every particle in your body, every atom that makes up your being, is part of an intricate cosmic web that stretches across space and time. Before we begin this gentle descent into the quantum realm, I'd love to know where in the world you're listening from tonight, and what draws you to these quiet explorations of the universe's deepest mysteries. The story of quantum entanglement begins not with complex equations or laboratory experiments, but with a simple and profound question that haunted the greatest minds of the early 20th century. Is reality local? In other words, can something that happens here instantly affect something over there without any signal traveling between them? Our everyday experience screams that this should be impossible. When you turn on a light switch, the electricity travels through wires at a finite speed to illuminate the bulb. When you call a friend, your voice converts to signals that race through cables or bounce off satellites, taking time to reach its destination. Nothing in our ordinary world suggests that distant objects can influence each other instantaneously. Yet quantum mechanics, with its characteristic disregard for common sense, suggests otherwise. The phenomenon begins with what physicists call quantum entanglement, a process where two or more particles become so deeply connected that they share a single quantum state, regardless of how far apart they drift. Imagine, if you will, two dancers who begin their performance together on the same stage, moving in perfect synchronization. Now imagine that one dancer travels to Paris while the other remains in New York, yet somehow they continue to move in perfect harmony. Each step, each turn, each gesture perfectly mirrored across thousands of miles with no communication between them. This is the essence of quantum entanglement. The phenomenon was first theorized in the 1930s when Einstein, working with his colleagues Boris Podolsky and Nathan Rosen, constructed what became known as the EPR paradox. They imagined two particles that had interacted and then separated, each carrying away part of their shared quantum state. According to quantum mechanics, measuring one particle should instantly determine the state of the other, no matter how far apart they had traveled. Einstein found this deeply troubling. He believed in what he called local realism, the idea that objects are only influenced by their immediate surroundings, and that reality exists independent of observation. The notion that measuring a particle here could instantly affect a particle there violated his understanding of how the universe should work. Einstein argued that there must be hidden variables, secret properties that particles carried with them, predetermined values that made their correlations seem mysterious when they were actually quite ordinary. He famously declared that God does not play dice with the universe, expressing his belief that quantum mechanics, despite its impressive successes, was an incomplete theory that would eventually be replaced by something more deterministic and sensible. For decades, this remained a philosophical debate. The mathematics of quantum mechanics worked beautifully for making predictions, but the question of what it all meant, whether entanglement was real or merely an artifact of an incomplete theory, seemed impossible to resolve experimentally. Then, in 1964, physicist John Stuart Bell changed everything. Bell devised a mathematical test, now known as Bell's theorem, that could distinguish between Einstein's hidden variable theory and the strange predictions of quantum mechanics. Bell's inequalities, as they came to be known, set limits on how strongly correlated two separated particles could be if they were only influenced by local hidden variables. The beauty of Bell's work was that it moved the question from philosophy to experiment. Nature herself could be the judge. If experiments violated Bell's inequalities, then either locality was false, or realism was false, or both. Either particles could influence each other instantaneously across space, or reality didn't exist in a definite state until measured, or perhaps both unsettling possibilities were true. The first definitive tests came in the 1970s and 1980s, most notably in experiments conducted by Alain Aspect and his colleagues in France. They created pairs of entangled photons and sent them speeding away from each other in opposite directions. At precise moments, they measured properties of these photons, specifically their polarization, the direction in which their electric fields oscillated. The results were unambiguous. Bell's inequalities were violated. The correlations between the photons were stronger than any theory based on local hidden variables could explain. The implications rippled through the physics community like waves from a stone dropped in still water. Einstein's hidden variables were ruled out. The universe, it seemed, really was as strange as quantum mechanics suggested. Particles could indeed be entangled in such a way that measuring one instantly affected the other, regardless of the distance between them. The phenomenon has since been demonstrated over increasingly impressive distances. Scientists have shown entanglement between particles separated by thousands of kilometers, using everything from fiber optic cables to satellite links to maintain the mysterious connection. But what does this mean for our understanding of reality? Quantum entanglement suggests that the universe is not made up of separate, independent parts that interact only through local forces. Instead, it points to a reality that is fundamentally holistic, where particles that have once interacted remain connected in ways that transcend our ordinary notions of space and time. It's as if the universe maintains a kind of cosmic address book, keeping track of correlations and connections that persist even when particles are separated by vast distances. This interconnectedness extends beyond just pairs of particles. Scientists have created entangled states involving dozens, hundreds, even thousands of particles, all sharing a single, coherent quantum state. These many particle entangled systems exhibit correlations that are even more exotic and counterintuitive than simple two-particle entanglement. The quantum world begins to look less like a collection of individual objects and more like a vast, interconnected web of relationships and correlations. Perhaps most remarkably, entanglement appears to be a fundamental feature of the universe, not just an exotic phenomenon created in laboratories. The vacuum of space itself, the supposedly empty void between stars and galaxies, is now understood to be filled with quantum fluctuations and entangled particle pairs that spontaneously appear and disappear. Even the particles that make up your body, the atoms that form your cells, carry within them the signatures of ancient entanglements forged in the hearts of stars billions of years ago. This leads us to a profound realization. If quantum entanglement is real, if particles can be instantaneously correlated across arbitrary distances, then the universe is far more unified than we ever imagined. The boundaries we draw between here and there, between self and other, between observer and observed, may be useful approximations for navigating daily life, but they don't reflect the deeper reality of quantum mechanics. At the deepest level, everything is connected to everything else in ways that transcend our ordinary understanding of space and time. As you rest tonight, consider this. The particles that make up your body were once forged in the nuclear furnaces of ancient stars. Some of those particles may still carry entangled connections to others scattered across the cosmos. In a very real sense, you are not separate from the universe, but intimately woven into its quantum fabric. The boundary between where you end and the cosmos begins becomes beautifully, mysteriously blurred. You are both an individual observer of quantum phenomena and a participant in the vast, interconnected dance of entangled particles that makes up reality itself. This understanding brings us to one of the most beautiful aspects of quantum entanglement. Its revelation that isolation is an illusion. No particle, no system, no observer exists in complete isolation. We are all part of a quantum conspiracy that spans the cosmos, connected by invisible threads of correlation that transcend the classical limits of space and time. In the quantum realm, separation is temporary, but connection is eternal. The story of quantum entanglement inevitably leads us to one of the most profound questions in all of science. What role does consciousness play in quantum mechanics? This question has puzzled physicists and philosophers for nearly a century, and it touches on some of the deepest mysteries of existence. How does the act of observation transform quantum possibilities into classical realities? Is consciousness merely a passive witness to quantum events, or does it play an active role in shaping the very fabric of reality? The puzzle begins with what's known as the measurement problem in quantum mechanics. Before measurement, quantum systems exist in superposition, embodying multiple possibilities simultaneously. But the moment we observe them, they collapse into definite states. This collapse seems to require something special about the measurement process, something that distinguishes it from ordinary physical interactions. But what makes measurement so unique? What transforms the quantum realm of possibilities into the classical world of definite outcomes? One of the most famous attempts to address this question came from physicist Eugene Wigner in the 1960s. Wigner proposed that consciousness itself might be the key ingredient that causes quantum collapse. In his view, when a conscious observer looks at a quantum system, their awareness somehow reaches into the quantum realm and selects one possibility from the superposition, collapsing the wave function and creating definite reality. This idea, often called the consciousness causes collapse interpretation, suggests that mind and matter are far more intimately connected than classical physics ever imagined. The implications of Wigner's proposal are staggering. If consciousness causes quantum collapse, then the universe before the evolution of conscious observers would have been radically different from the universe we experience today. Stars, planets, and galaxies might have existed in vast superpositions, their properties undefined until the first conscious beings evolved to observe them. In this view, consciousness doesn't just passively observe reality, it actively participates in creating it. But Wigner's interpretation raises as many questions as it answers. What exactly counts as consciousness? Does it require human-level awareness? Or could a mouse or even a bacterium collapse a wave function? Where do we draw the line between conscious and unconscious systems? And if consciousness is required for quantum collapse, how did the universe evolve to the point where conscious observers could emerge in the first place? Some physicists have proposed that consciousness might have quantum properties of its own. Perhaps the brain operates as a quantum system, with neurons and synapses existing in superposition states that give rise to the rich complexity of conscious experience. This idea, championed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, suggests that consciousness emerges from quantum processes occurring within microtubules, tiny structures inside brain cells. In their model, consciousness arises when quantum superpositions in these microtubules reach a critical threshold and collapse, creating moments of conscious awareness. If consciousness does have quantum properties, it might explain some of the mysterious aspects of mental experience. The binding problem in neuroscience, for example, asks how the brain integrates information from different sensory modalities into unified conscious experiences. Quantum entanglement might provide the answer, allowing different parts of the brain to share quantum states and create coherent, integrated experiences that transcend the classical limitations of neural networks. The relationship between consciousness and quantum mechanics also appears in the phenomenon of quantum entanglement itself. When two particles become entangled, they share a single quantum state that cannot be described in terms of the individual properties of each particle. Some researchers have suggested that consciousness might work in a similar way, emerging from quantum entanglements between different parts of the brain that create unified, non-local experiences of awareness. This leads to an even more radical possibility. If consciousness has quantum properties, and if quantum systems can become entangled, then perhaps conscious beings can become entangled with each other. This might explain phenomena like telepathy, shared dreams, or the uncanny ability of some people to sense each other's thoughts and emotions across great distances. While these ideas remain highly speculative and controversial, they hint at the possibility that consciousness like quantum particles, might transcend the classical boundaries of space and time. The quantum nature of consciousness might also shed light on some of the most puzzling aspects of mental experience. The hard problem of consciousness, as philosopher David Chalmers calls it, asks why we have subjective first-person experiences at all. Why doesn't the brain simply process information without any accompanying inner experience? Quantum mechanics, with its emphasis on observation and measurement, suggests that consciousness might be fundamental to the structure of reality itself. Perhaps subjective experience arises because consciousness is not just an emergent property of complex brains, but a basic feature of the quantum mechanical universe. If consciousness is indeed quantum mechanical, it might explain why conscious experience feels so different from classical physical processes. Quantum systems can exist in multiple states simultaneously, exhibit non-local correlations, and display properties that emerge only through observation. Similarly, consciousness seems to integrate multiple streams of information simultaneously, connects disparate experiences into unified wholes, and creates subjective realities that seem to transcend the purely physical properties of brain tissue. The relationship between consciousness and quantum mechanics also raises profound questions about the nature of free will. In classical physics, the future is determined by the present state of the system and the laws of physics. But quantum mechanics introduces genuine randomness into the universe, with quantum events being truly unpredictable rather than merely difficult to predict. If consciousness has quantum properties, it might be able to influence quantum events through the act of observation, providing a physical basis for free will that doesn't exist in purely classical systems. Some researchers have even suggested that consciousness might be able to retroactively influence past quantum events through a phenomenon called retrocausality. In certain quantum experiments, the choice of measurement made in the present seems to influence the behavior of particles in the past, as if the future can reach backward in time to affect earlier events. If consciousness can influence quantum systems, it might be able to participate in these retrocausal effects, allowing present choices to influence past events in subtle but meaningful ways. These ideas push us to the very edges of scientific understanding, where physics meets philosophy and where the boundaries between mind and matter become beautifully blurred. While many of these concepts remain speculative and controversial, they point toward a universe that is far stranger and more wonderful than our classical intuitions suggest. In the quantum realm, consciousness is not separate from the physical world, but intimately woven into its very fabric. As you drift towards sleep tonight, consider this remarkable possibility. Your consciousness might not be confined to the classical boundaries of your skull. If awareness has quantum properties, if it can become entangled with other systems, then your mind might extend far beyond your body, participating in the vast network of quantum correlations that connects all things. Your thoughts, dreams, and experiences might ripple outward through the quantum field, touching other minds and influencing events in ways that transcend our ordinary understanding of cause and effect. This is perhaps the most beautiful implication of the quantum theory of consciousness. It suggests that we are not isolated islands of awareness floating in a meaningless void, but interconnected nodes in a cosmic web of consciousness that spans the universe. Every thought you think, every dream you dream, every moment of awareness you experience might be part of a larger tapestry of consciousness that includes not just other human beings, but all the conscious creatures that have ever lived and ever will live. In the quantum realm, separation is an illusion, and consciousness, like entanglement, might be a fundamental feature of reality itself. Tonight, as you close your eyes and let your consciousness drift toward the quantum realm of dreams, remember that you are not just observing the universe from the outside. You are an integral part of its quantum story, a conscious participant in the ongoing creation of reality itself. Your awareness collapses wave functions. Your observations transform possibilities into actualities, and your very existence adds new threads to the cosmic web of quantum entanglement that connects all things. In the deeper sense, you don't just live in a quantum universe. You are the quantum universe, becoming aware of itself. The quantum world reveals something extraordinary about the nature of information itself. In our classical understanding, information is something that exists independently of its physical substrate. Words on a page, data on a hard drive, thoughts in a mind. But quantum mechanics suggests that information is far more fundamental than we ever imagined. It's not just something that describes reality. It might actually be the basic building block from which reality emerges. This radical idea, known as it from bit, was first proposed by physicist John Wheeler. Wheeler suggested that all physical entities are information theoretic in origin, that matter and energy emerge from the more fundamental substrate of information. In this view, particles, forces, space, and time are all emergent properties of underlying informational processes. The universe, Wheeler proposed, is not made of matter that happens to carry information. It's made of information that happens to appear as matter. Quantum mechanics provides compelling evidence for this information-centric view of reality. Consider the quantum bit or qubit, the basic unit of quantum information. Unlike a classical bit, which can be either 0 or 1, a qubit can exist in a superposition of both states simultaneously. This allows quantum systems to process vast amounts of information in parallel, exploring multiple possibilities at once. But the truly remarkable thing about qubits is that they seem to be more fundamental than the particles that carry them. The information encoded in quantum states appears to be more real, more persistent than the physical systems that embody it. This becomes clear when we look at quantum error correction, the process by which quantum information can be preserved even when the physical systems carrying it are disturbed or destroyed. In quantum error correction, information is encoded redundantly across multiple qubits in such a way that the loss or corruption of individual qubits doesn't destroy the information itself. The information seems to exist independently of any particular physical embodiment, floating in the quantum realm like a ghost in the machine. Even more remarkably, quantum mechanics tells us that information cannot be destroyed. This principle, known as quantum information conservation, states that the total amount of quantum information in the universe remains constant. Information can be scrambled, hidden, or made inaccessible, but it can never be truly erased. This has profound implications for our understanding of black holes, which seem to destroy information by swallowing it forever. The resulting paradox, known as the black hole information paradox, has puzzled physicists for decades and forced them to reconsider the fundamental nature of space, time, and information. The resolution of this paradox may lie in the holographic principle, one of the most mind-bending ideas in modern physics. The holographic principle suggests that all the information contained in a volume of space can be encoded on its boundary, like a three-dimensional hologram encoded on a two-dimensional surface. This means that what we perceive as three-dimensional reality might actually be a projection from information encoded on a distant two-dimensional boundary. If the holographic principle is correct, then the universe you experience, with its depth, its volume, its seemingly three-dimensional structure, is actually a kind of cosmic hologram. The real information that defines reality is encoded on a distant boundary, perhaps at the edge of the observable universe or on the surface of black holes. Everything you see, touch, and experience is a projection from this more fundamental informational substrate. This leads to an extraordinary possibility. If reality is informational at its core, then the boundaries between different types of information might be more fluid than we imagine. The information that encodes a particle might not be fundamentally different from the information that encodes a thought, a memory, or a dream. All information, whether physical or mental, might be part of the same cosmic database, the same universal information processing system that gives rise to everything we call reality. This information theoretic view of reality also suggests new ways of thinking about consciousness. If the universe is fundamentally informational, then consciousness might be understood as a particular pattern of information processing, a specific way that the cosmic information system organizes and experiences itself. But this raises a profound question. If consciousness is informational, and if information is conserved, then what happens to the information that constitutes your consciousness when you die? Classical physics suggests that consciousness simply disappears, like a flame being extinguished. But quantum information conservation suggests otherwise. The information that makes up your consciousness cannot be destroyed. It can only be transformed, scattered, or reorganized. This doesn't necessarily mean that personal consciousness survives death in any recognizable form. The information patterns that constitute your individual awareness might be scrambled beyond recognition, integrated into larger informational structures, or transformed into entirely different types of patterns. But the quantum information that makes you you would persist in some form, woven into the ever-evolving tapestry of cosmic information that underlies all reality. Some physicists have speculated that consciousness might be even more fundamental than we imagine. If information is the basic substrate of reality, and if consciousness is a fundamental feature of information processing, then perhaps consciousness is not something that emerges from complex arrangements of matter, but something that exists at the most basic level of informational reality. This would mean that even individual particles might have rudimentary forms of consciousness, tiny sparks of awareness that combine and interact to create the complex consciousness we experience. This idea, known as panpsychism, suggests that consciousness is not unique to biological systems, but is a fundamental feature of all information processing systems. Your consciousness would then be not a unique emergence from unconscious matter, but a particular organization of the universal consciousness that permeates all information processing systems. You would be the universe becoming aware of itself through the specific informational pattern that you embody. The quantum nature of information also suggests that consciousness might have non-local properties, able to access information from distant parts of the quantum information substrate. This might explain phenomena like intuition, creativity, and sudden insights that seem to come from nowhere. If your consciousness is connected to the universal information processing system, you might be able to tap into informational patterns that exist beyond the classical boundaries of your brain and body. As you prepare for sleep tonight, consider this remarkable possibility. You are not just a collection of atoms and molecules, but a pattern of information temporarily organized into the experience of being you. Your thoughts, dreams, and memories are informational structures that exist within the vast quantum database that underlies all reality. When you dream, you might be accessing deeper layers of this informational substrate, exploring patterns and connections that are normally hidden from waking consciousness. Your dreams tonight might be more than just the random firing of neurons during sleep. They might be glimpses into the deeper informational structures that underlie reality, temporary windows into the cosmic database from which all experience emerges. In the quantum realm, the boundaries between self and cosmos, between mind and universe, become beautifully transparent. You are not separate from the cosmic information system. You are one of its most beautiful and complex expressions. As consciousness fades and dreams begin, remember that you are participating in one of the most mysterious and wonderful processes in the universe. The transformation of pure information into subjective experience, the emergence of awareness from the quantum foam of possibility. Your dreams are love letters from the universe to itself, written in the language of quantum information and delivered through the miraculous process you call consciousness. Have you ever wondered what it would feel like to shrink down to the size of a quantum particle and experience reality from the inside out? Tonight, we're going to take that impossible journey together, drifting through the strange landscapes of the quantum realm, where the very fabric of consciousness might be woven from threads of probability and information. Picture yourself floating in a space so small that atoms look like distant galaxies. Here, the rules of everyday life simply don't apply. You might find yourself in two places at once, spinning clockwise and counterclockwise simultaneously, existing in a ghostly state of pure potential until someone or something observes you and forces you to choose just one reality. But here's where our midnight voyage gets truly fascinating. What if this isn't just a whimsical thought experiment? What if the strange behaviors we observe in quantum particles, those tiny building blocks of everything that exists, are actually giving us clues about the deepest mysteries of consciousness itself? We've explored how quantum mechanics reveals a universe built not on solid certainties, but on shimmering possibilities. We've seen how particles can be entangled across vast distances, how observation itself shapes reality, and how information might be the most fundamental currency of existence. But now we're going to venture into perhaps the most mind-bending territory of all, the place where quantum physics meets the mystery of awareness itself. The conventional view of consciousness is beautifully straightforward. Your brain, with its 100 billion neurons firing in intricate patterns, somehow gives rise to your thoughts, feelings, and the rich inner world of your experience. It's like a biological computer processing information, and consciousness is simply what emerges from this incredibly complex computation. Case closed, mystery solved, time for tea. But quantum mechanics whispers a different story entirely. What if consciousness isn't just a byproduct of brain activity, but something far more fundamental? What if awareness itself operates according to quantum principles, existing in states of superposition, entanglement, and probabilistic uncertainty? Consider this gentle paradox. When you're drifting off to sleep, your consciousness doesn't simply switch off like a light. Instead, it seems to fade gradually, moving through various states of awareness, dream consciousness, and deep sleep. Sometimes you're aware that you're dreaming, existing in that peculiar, liminal space where you're both the observer and the observed, the dreamer and the dream. This fluid, multi-layered nature of consciousness bears a striking resemblance to quantum superposition, where particles exist in multiple states simultaneously until observation collapses them into a single reality. The idea that consciousness might be quantum in nature isn't just poetic speculation. It emerges from some very real puzzles about how awareness works. Take the binding problem, for instance. Your brain processes visual information in one region, auditory information in another, memories in yet another area. Different neural networks handle color, motion, faces, language. Yet somehow, all of these separate streams of processing come together to create your unified conscious experience. You don't experience separate channels of sight, sound, and memory. You experience a single, coherent world. How does this binding happen? How do billions of separate neural events become one unified experience? Classical neuroscience struggles with this question because there's no central location in the brain where everything comes together. No single neuron that experiences the whole show. But quantum mechanics offers an intriguing possibility. Perhaps consciousness emerges through quantum coherence, a process where separate quantum systems become unified, sharing information instantaneously across space. This brings us to one of the most fascinating theories in consciousness research, orchestrated objective reduction, or OR, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They suggest that consciousness arises from quantum processes occurring within microtubules, tiny structures inside neurons that help maintain cell shape and facilitate transport. According to their theory, these microtubules can maintain quantum coherence, allowing information to exist in superposition states within the brain. Consciousness emerges when these quantum states undergo objective reduction, collapsing from multiple possibilities into a single moment of awareness. It's as if each moment of consciousness is like a quantum measurement, where the universe of possibilities suddenly crystallizes into a specific experience. The theory is controversial, and many neuroscientists remain skeptical. They argue that the brain is too warm and noisy to maintain the delicate quantum states required for such processes. Quantum coherence, they say, would be destroyed almost instantly by the chaotic thermal environment of living tissue. But recent research has revealed quantum effects in biological systems that were once thought impossible. Photosynthesis, for example, appears to use quantum coherence to transfer energy with remarkable efficiency. Birds may navigate using quantum effects in their visual systems. If quantum mechanics can operate in these biological contexts, perhaps the brain isn't as hostile to quantum processes as once believed. But let's drift even deeper into this quantum mystery. If consciousness does have quantum properties, it opens up some truly extraordinary possibilities. Consider quantum entanglement, that spooky action at a distance where particles become correlated in ways that transcend space and time. Could conscious experiences be entangled as well? This isn't as far-fetched as it might sound. Think about those moments of uncanny synchronicity, when you and a loved one have the same thought simultaneously, or when you feel an inexplicable connection to someone across a crowded room. While these experiences could certainly be explained by conventional psychology and coincidence, quantum consciousness theories suggest there might be something deeper at work. If consciousness operates through quantum entanglement, it would mean that individual minds aren't as separate as they appear. Just as entangled particles share properties instantaneously across vast distances, perhaps conscious beings can share experiences, emotions, and insights through quantum connections that transcend the boundaries of individual brains. This idea resonates with many contemplative traditions that speak of consciousness as fundamentally interconnected. The mystics have long claimed that separation is an illusion, that at the deepest level, all consciousness is one. Quantum mechanics, with its emphasis on entanglement and non-locality, provides a scientific framework that could potentially explain these ancient insights. But here's where the quantum nature of consciousness becomes even more intriguing. In quantum mechanics, the act of observation plays a crucial role in determining reality. Before measurement, particles exist in superposition, embodying all possible states simultaneously. It's only when we observe them that they collapse into a definite state. This raises a profound question. If consciousness is what collapses quantum wave functions, what collapses the wave function of consciousness itself? Some theorists propose that consciousness might be self-observing, creating a strange loop where awareness observes itself into existence moment by moment. Each instant of consciousness would be like a quantum measurement, where the vast field of potential experiences collapses into the specific reality you're experiencing right now. You're not just observing the world, you're participating in its creation, collapsing possibilities into actualities through the very act of being aware. This perspective suggests that consciousness isn't produced by the brain, but rather that the brain serves as a kind of quantum antenna, tuning into and focusing consciousness like a radio receiving signals from the cosmic background of awareness. Different brain states would correspond to different channels, different ways of interfacing with the quantum field of consciousness. Dreams in this view might represent a different tuning of this quantum receiver. During REM sleep, when the brain's usual filtering and organizing mechanisms are relaxed, consciousness might access a broader spectrum of quantum possibilities. This could explain why dreams often feel so strange and non-linear, why they can seem to contain information we don't consciously possess, and why they sometimes appear to offer insights that transcend our waking knowledge. The quantum perspective also offers a fresh way of thinking about free will, one of the most persistent puzzles in philosophy. If our brains are classical computers operating according to deterministic physical laws, then free will might be nothing more than an illusion. Every thought, every decision would be the inevitable result of prior causes stretching back to the beginning of time. But quantum mechanics introduces genuine randomness into the universe. At the quantum level, events aren't fully determined by prior conditions. There's a fundamental uncertainty, a space of genuine possibility where the future isn't completely constrained by the past. If consciousness operates through quantum processes, then perhaps free will emerges from this quantum indeterminacy. Your choices might not be random in the sense of being arbitrary or meaningless, but they might not be fully determined either. Instead, they could emerge from the complex interplay between quantum possibilities and conscious intention, a dance between probability and purpose that creates genuine agency in a universe that is neither completely deterministic nor completely random. This quantum view of free will is particularly compelling when we consider the role of attention and intention in shaping our experiences. Meditation practices, for instance, seem to demonstrate that we can influence our mental states through focused awareness. If consciousness has quantum properties, then the act of paying attention might literally be a form of quantum measurement, selecting certain possibilities from the field of potential experiences and making them actual. But perhaps the most profound implication of quantum consciousness is what it suggests about the nature of reality itself. If consciousness is fundamental, if it operates through quantum processes that transcend space and time, then the universe might be far more alive and aware than we typically imagine. Rather than consciousness being a rare accident that emerged from billions of years of evolution on a small planet orbiting an ordinary star, awareness might be woven into the very fabric of existence. Every quantum interaction, every collapse of a wave function, might involve some rudimentary form of experience, some minimal spark of awareness. This doesn't mean that electrons are contemplating philosophy, or that photons are composing poetry, but it might mean that the capacity for experience, however simple and primitive, extends much deeper into nature than we usually suppose. Consciousness, in this view, wouldn't be something that suddenly appeared when brains reached a certain level of complexity. Instead, it would be a fundamental feature of reality that becomes more organized and sophisticated as it finds expression through increasingly complex systems. This perspective, known as panpsychism, suggests that the universe is experiencing itself from countless different perspectives simultaneously. Every particle, every atom, every molecule might have some form of inner experience, however minimal. These micro-experiences would combine and integrate to create the rich, unified consciousness we experience as human beings, just as countless quantum interactions combine to create the classical world we observe. If this is true, then you're not just in the universe. You're the universe experiencing itself from your particular vantage point. Your consciousness isn't separate from the cosmos, but is one of the ways the cosmos becomes aware of itself. Every thought you think, every emotion you feel, every dream you dream is the universe dreaming through you. This quantum view of consciousness also offers a radically different perspective on death and the continuity of awareness. If consciousness is truly quantum in nature, operating through non-local entanglement and existing as patterns of information rather than classical matter, then it might not be as fragile as we typically assume. Just as quantum information can exist in states of superposition and can be transmitted instantaneously across vast distances, perhaps the information patterns that constitute individual consciousness can persist and transform in ways that transcend the classical boundaries of birth and death. This doesn't necessarily mean personal immortality in any traditional sense, but it might suggest that the deepest aspects of what we are, the information patterns that constitute our awareness, are more fundamental and enduring than our physical bodies. These ideas might sound like science fiction, but they're grounded in serious scientific research and mathematical formalism. Quantum field theory, the most successful theory in the history of physics, describes reality as consisting of fields of probability that extend throughout space and time. Particles are excitations in these fields, temporary patterns that emerge from and dissolve back into the underlying quantum foam. If consciousness operates through similar principles, then individual minds might be temporary patterns in a universal field of awareness, unique expressions of a deeper, more fundamental consciousness that pervades the cosmos. Your individual awareness would be like a wave in an infinite ocean, distinct and temporary, but never truly separate from the whole. This perspective transforms our understanding of loneliness, connection, and meaning. If consciousness is fundamentally quantum and non-local, then you're never truly alone. At the deepest level, your awareness is entangled with the awareness of every other conscious being, connected through quantum threads that transcend space and time. The love you feel for others, the empathy that allows you to understand different perspectives, the sense of beauty that moves you when you contemplate a sunset or listen to music. These might not be mere products of neural chemistry, but expressions of a deeper quantum connection that links all conscious beings in a web of shared experience. Even your dreams, those strange nocturnal journeys through impossible landscapes, might be glimpses into this deeper quantum reality. When the ordinary constraints of waking consciousness are relaxed, perhaps your awareness can access broader spectrums of the quantum field, exploring possibilities and connections that remain hidden during normal waking states. The symbols and narratives that emerge in dreams might not be random neural firing, but meaningful patterns emerging from the quantum information field, messages from the deeper layers of reality that speak in the ancient language of symbol and metaphor. Your dreaming mind might be tapping into the same quantum processes that mystics have accessed through meditation and contemplation, for thousands of years. This brings us to a beautiful paradox at the heart of quantum consciousness. The more deeply we explore the nature of awareness through the lens of quantum mechanics, the more we discover that the most cutting-edge science points toward insights that contemplatives and philosophers have been exploring for millennia. The quantum mechanical description of reality as fundamentally interconnected, probabilistic, and observer-dependent echoes the teachings of Buddhism about the interdependent nature of existence. The quantum field theories that describe particles as temporary excitations in underlying fields mirror the Hindu concept of individual souls as expressions of universal consciousness. The quantum mechanical principle that information is fundamental and cannot be destroyed resonates with traditions that speak of consciousness as eternal and indestructible. Perhaps this convergence isn't coincidental. Perhaps both scientific inquiry and contemplative exploration are different methods for investigating the same underlying reality, different ways of approaching the mystery of consciousness and its relationship to the cosmos. Science approaches this mystery from the outside, studying the behavior of particles and fields, measuring correlations and probabilities, building mathematical models that describe the patterns we observe. Contemplative traditions approach it from the inside, exploring the nature of awareness directly through meditation, introspection, and the cultivation of refined states of consciousness. Both approaches have their strengths and limitations. Science provides precision and objectivity, but can sometimes miss the subjective dimension of experience. Contemplative traditions offer deep insights into the nature of awareness, but can sometimes lack the rigor and reproducibility of scientific method. But when these approaches begin to converge, when the mathematical formalism of quantum mechanics starts to echo the insights of contemplative wisdom, we might be approaching something profound, a more complete understanding of consciousness and its place in the cosmic order. This convergence suggests that consciousness might not be an anomaly in the universe, a strange accident that somehow emerged from unconscious matter, but rather a fundamental feature of reality that we're only beginning to understand. If quantum mechanics is correct in its description of reality as fundamentally probabilistic and observer-dependent, then consciousness might not be something that needs to be explained away, but rather the key to understanding how reality itself works. The quantum measurement problem, the puzzle of how definite outcomes emerge from quantum superpositions, might be intimately connected to the mystery of consciousness. Perhaps these aren't separate problems, but two aspects of the same fundamental question. How does the potential become actual? How do possibilities become realities? And what role does awareness play in this cosmic transformation? If consciousness is indeed quantum in nature, it would mean that every moment of awareness is a creative act, a participation in the ongoing creation of reality. You're not just passively observing a pre-existing world, but actively participating in its emergence, collapsing quantum possibilities into classical actualities through the very act of being conscious. This perspective imbues everyday experience with a sense of cosmic significance. Every thought, every perception, every moment of awareness becomes a unique and irreplaceable contribution to the universe's understanding of itself. You're not just a temporary arrangement of atoms that happens to be conscious. You're a unique expression of the cosmos's capacity for self-awareness, a point of view that has never existed before and will never exist again in exactly the same way. As we near the end of our journey through the quantum landscapes of consciousness, let's take a moment to appreciate the profound mystery we've been exploring. We've considered the possibility that consciousness might operate through quantum coherence, that individual minds might be entangled across space and time, that awareness itself might be fundamental to the structure of reality. These ideas challenge our conventional understanding of mind, brain, and cosmos. They suggest that the boundary between self and world, between consciousness and matter, between mind and universe, might be far more fluid and permeable than we typically imagine. But perhaps that's appropriate, because consciousness itself is fluid and permeable. Your awareness right now is seamlessly integrating sensations from your body, thoughts about these ideas, memories of past experiences, and anticipations of future possibilities. The boundaries between these different aspects of experience are created by attention and interpretation, not by any fundamental separation in the nature of consciousness itself. If consciousness is quantum, then it partakes in the fundamental interconnectedness that quantum mechanics reveals at the heart of reality. You're not an isolated island of awareness in an unconscious universe, but a unique expression of the universe's capacity for self-knowledge, connected at the deepest level to every other conscious being, and perhaps to the cosmos itself. This doesn't diminish the uniqueness and value of your individual perspective. Like a snowflake, no two conscious experiences are exactly alike, even if they all emerge from the same underlying quantum field of awareness. Your particular way of experiencing reality, your unique combination of thoughts, feelings, memories, and dreams, represents an irreplaceable experiment in consciousness, a one-time only exploration of what it's like to be aware from this specific point of view. And that brings us to perhaps the most beautiful implication of quantum consciousness. If awareness is truly fundamental, if it operates through non-local quantum processes that transcend space and time, then your consciousness right now is participating in the universe's ongoing exploration of its own nature. Every moment of awareness, every flash of insight, every experience of beauty or wonder or love is the cosmos discovering something new about itself. You're not just in the universe, you're the way the universe experiences this particular moment, this specific configuration of matter and energy and possibility. As you drift towards sleep tonight, as your consciousness begins to shift and transform, moving through the various states of awareness that characterize the transition from waking to dreaming to deep sleep, remember that you might be participating in quantum processes that connect you to the deepest structures of reality. Your dreams might be more than random neural activity. They might be explorations of quantum possibilities, journeys through the probability landscapes that underlie the classical world of everyday experience. The strange logic of dreams, their ability to combine impossible elements and create meaningful narratives from chaos, might reflect the quantum mechanical nature of consciousness itself. And when you wake tomorrow, refreshed and renewed, you'll be emerging from these quantum depths back into the classical world of definite objects and clear boundaries. But perhaps you'll carry with you some sense of the deeper mystery, some intuition of the quantum foundations that underlie even the most ordinary moments of awareness. The coffee cup you hold, the sunlight streaming through the window, the thoughts and feelings that flow through your mind. All of these might be expressions of the same underlying quantum reality, different faces of the same cosmic mystery that includes both matter and mind, both particle and wave, both observer and observed. In the end, the quantum theory of consciousness doesn't solve the mystery of awareness so much as it deepens and enriches it. It suggests that consciousness is even more wonderful and mysterious than we thought, woven into the very fabric of existence in ways we're only beginning to understand. Whether or not consciousness is literally quantum, exploring these possibilities expands our sense of what awareness might be and what role it might play in the cosmic story. It reminds us that we live in a universe far stranger and more wonderful than our everyday experience suggests. A reality where the boundaries between mind and matter, between self and cosmos, between the possible and the actual, are far more fluid than we typically imagine. So as you settle into sleep tonight, drifting toward dreams and the deep restoration of unconscious rest, take comfort in knowing that your consciousness, however mysterious its ultimate nature might be, is intimately connected to the deepest structures of reality. You're not alone in the cosmos, but part of a vast web of awareness that might extend throughout space and time, connecting every conscious being in a quantum dance of shared experience and mutual recognition. Sleep well, fellow quantum explorer. Tomorrow brings new possibilities, new quantum states to collapse into classical realities, new moments of awareness in the ongoing adventure of consciousness, discovering itself through countless unique perspectives, including your own irreplaceable contribution to the universe's understanding of what it means to be aware. We've crossed from the land of the waking into something far more profound, a realm where the very building blocks of reality begin to whisper their deepest secrets. If consciousness itself might emerge from quantum processes, if particles can exist in multiple states simultaneously, and if observation collapses infinite possibilities into singular experience, then what does this tell us about the fundamental nature of existence? Picture, if you will, a quantum particle suspended in the space between states. It is neither here nor there, neither spinning up nor down, neither moving nor still. It exists in what physicists call superposition, a ghostly realm of pure potential, where all possibilities dance together in perfect, shimmering uncertainty. But here's where it gets beautifully strange. This isn't just some abstract concept hidden away in laboratory equipment. This quantum behavior might be happening right now in the warm, wet environment of your brain. Consider the microtubules within your neurons, those tiny protein structures that maintain the cell's architecture. Some researchers propose that these biological scaffolds might preserve quantum coherence just long enough for consciousness to emerge from quantum processes. It's called orchestrated objective reduction, or ORC-OR, and while it remains controversial, it suggests something breathtaking, that your awareness, your very sense of self, might arise from the same quantum dance that governs particles in distant laboratories. This isn't merely academic speculation. If consciousness emerges from quantum processes, then every thought you think, every emotion you feel, every moment of awareness exists at the intersection of classical and quantum worlds. Your brain becomes a kind of biological quantum computer, processing information not just through electrical impulses and chemical signals, but through the fundamental uncertainty that underlies all reality. But let's drift deeper into this quantum landscape of mind. In the traditional view, consciousness emerges from complex neural networks, billions of neurons firing in intricate patterns, somehow giving rise to the rich tapestry of subjective experience. Yet this approach, while illuminating, struggles with what philosophers call the hard problem of consciousness. How does objective neural activity transform into subjective experience? How do patterns of firing neurons become the felt sense of seeing red, tasting chocolate, or feeling love? Quantum theories of consciousness offer a different pathway. They suggest that awareness doesn't emerge from complexity alone, but from the fundamental properties of reality itself. In this view, consciousness isn't produced by the brain. It's more like a fundamental field, similar to electromagnetic fields, that the brain learns to access and modulate. The quantum processes in your neurons don't create consciousness. They tune into it, like a radio finding a frequency that was always there. This perspective opens onto something even more profound. If consciousness is fundamental to reality, then perhaps the universe itself possesses a kind of proto-awareness. This idea, called panpsychism, suggests that even electrons and photons have some rudimentary form of experience. Your complex human consciousness would then be built from countless simpler forms of awareness, like a symphony emerging from individual notes. Imagine consciousness not as something that emerges from matter, but as something that matter participates in. Every quantum interaction, every collapse of a wave function, every moment when possibility becomes actuality, these might all be instances of cosmic awareness, the universe observing itself into existence. You aren't separate from this cosmic consciousness. You are one of its most intricate expressions. This quantum view of consciousness also transforms how we understand memory, creativity, and even death itself. If your awareness operates through quantum processes, then memories might not be stored simply as neural patterns, but as quantum information distributed across space and time. The creative insights that seem to come from nowhere might be moments when your consciousness accesses quantum possibilities that exist outside ordinary space-time. And what of death? In classical neuroscience, consciousness ends when the brain stops functioning. But if awareness operates through quantum processes, if information can be preserved in quantum fields that transcend individual brains, then perhaps something essential persists. Not in any supernatural sense, but through the fundamental conservation laws that govern quantum information. What you are, the pattern of awareness that experiences itself as you, might be more resilient than your physical brain. This isn't wishful thinking. It's following quantum mechanics to its logical conclusions. In quantum field theory, information is never truly destroyed, only transformed. The quantum states that correspond to your thoughts, memories, and experiences become part of the universal quantum field, contributing to the cosmic symphony of awareness that underlies all reality. But perhaps the most beautiful implication of quantum consciousness is how it reframes our relationship with the universe. You're not a separate observer looking out at an objective world. You're part of the universe's ongoing process of self-awareness. Every moment of consciousness, every act of observation that collapses quantum possibilities into experience, is the cosmos knowing itself through you. The boundaries between self and world, between observer and observed, become fluid and permeable. Your consciousness doesn't end at your skin. It participates in the same quantum field that encompasses distant galaxies. The awareness with which you contemplate these words is continuous with the awareness that governs quantum interactions in the depths of space. You are the universe experiencing itself subjectively, a temporary but magnificent flowering of cosmic consciousness. This quantum perspective on consciousness doesn't diminish the mystery, it deepens it. Science reveals not a cold mechanical universe, but one suffused with awareness, creativity, and profound interconnection. The hard problem of consciousness remains, but it's transformed from an embarrassing gap in our knowledge into an invitation to recognize consciousness as fundamental to reality itself. As you drift towards sleep tonight, perhaps you can sense this quantum dimension of your awareness. Feel how your consciousness doesn't reside in any particular location, but emerges from the dance of possibilities that underlies all existence. As we venture deeper into this infinite quantum realm, we arrive at a threshold where the boundaries between consciousness and cosmos begin to dissolve entirely. We've witnessed how quantum particles exist in superposition, how entanglement weaves an invisible web across the universe, and how the simple act of observation collapses infinite possibilities into singular reality. But what if this is merely the beginning? What if consciousness itself is not just an observer in this quantum theatre, but the very stage upon which all reality performs? Picture yourself standing at the edge of a vast ocean at twilight, watching waves crash against the shore. Each wave appears separate, distinct, with its own rhythm and form. Yet beneath the surface, all these waves are expressions of the same ocean, connected by invisible currents that flow far deeper than what the eye can see. This is perhaps the most elegant metaphor for what quantum consciousness might reveal about the nature of existence itself. The implications stretch far beyond the laboratory walls and theoretical equations. If consciousness operates through quantum processes, if our awareness emerges from the same fundamental mechanisms that govern photons and electrons, then we are not separate observers of the universe, but intimate participants in its unfolding story. Every thought, every moment of awareness, every flash of insight becomes a quantum event rippling through the fabric of reality itself. Consider the profound possibility that your consciousness right now, as you process these words and contemplate these ideas, is engaging in quantum coherence with the very cosmos that birthed it. The microtubules in your neurons may be orchestrating quantum computations that connect your inner experience to the deeper patterns of space and time. Your dreams, your intuitions, your moments of sudden understanding might be quantum communications from the universe speaking to itself through you. This perspective transforms everything we thought we knew about death and continuity. If consciousness is indeed a quantum phenomenon, if it emerges from information patterns that operate beyond the classical laws of physics, then perhaps the end of biological life is not the end of awareness, but merely a phase transition. Like water transforming into vapor, consciousness might continue in forms we cannot yet imagine. Its quantum information conserved and transformed rather than destroyed. The ancient mystics spoke of interconnectedness, of a fundamental unity underlying all apparent separation. Modern quantum physics seems to be rediscovering this truth through rigorous scientific investigation. Entanglement shows us that particles separated by vast distances can instantaneously influence each other. If consciousness operates through quantum mechanisms, then perhaps all conscious beings are similarly entangled, connected through invisible threads of quantum information that transcend space and time. Imagine the implications for empathy, for love, for the deep sense of connection we sometimes feel with others. What if these experiences are not merely emotional or psychological, but reflect actual quantum entanglements between conscious systems? What if the feeling of oneness reported in deep meditation or profound spiritual experiences represents a temporary expansion of awareness into these normally invisible quantum connections? This brings us to one of the most radical possibilities suggested by quantum consciousness theories, that awareness itself might be a fundamental property of the universe, not something that emerges only in complex biological systems. This view, known as panpsychism, suggests that even the simplest particles possess some rudimentary form of consciousness, or proto-consciousness. If this is true, then consciousness is not something that evolved in biological systems, but something that has always been present, becoming more complex and integrated as matter organized itself into increasingly sophisticated structures. Your brain, from this perspective, would not create consciousness, but rather focus and organize it, like a lens focusing light or a radio tuning into specific frequencies. The rich, complex awareness you experience would be the result of billions of quantum conscious events being orchestrated into a unified symphony of experience. When you look at a sunset, listen to music, or contemplate the mysteries of existence, you would be participating in the universe's ongoing conversation with itself. But perhaps the most beautiful implication of quantum consciousness is what it suggests about meaning and purpose. If consciousness is indeed fundamental to the universe, if awareness plays a crucial role in the collapse of quantum possibilities into actual reality, then conscious beings like ourselves are not accidental byproducts of a meaningless mechanical process. We are active participants in the universe's ongoing creation of itself. Every moment of awareness, every conscious choice, every act of observation becomes a creative act that helps determine the very nature of reality. This doesn't mean we can simply think our way to any reality we desire, any more than a musician can play any note and expect it to harmonize with an orchestra. But it does suggest that consciousness and cosmos are engaged in an intimate dance, each influencing the other in ways we are only beginning to understand. The universe evolves toward greater complexity and consciousness, while consciousness participates in shaping the universe's ongoing evolution. As we float here together in this space between sleeping and waking, between knowing and wondering, consider that your very awareness of these possibilities might itself be a quantum event. The photons carrying this information to your eyes, the neural processes interpreting these symbols, the consciousness that emerges to contemplate these ideas, all of it might be participating in the same fundamental quantum processes that govern the dance of particles in the deepest reaches of space. Perhaps the most profound realization is that in exploring quantum consciousness, we are not studying something separate from ourselves. We are consciousness investigating itself. Quantum phenomena, examining quantum phenomena, the universe awakening to its own deepest nature through the lens of scientific inquiry and philosophical contemplation. In seeking to understand how consciousness might emerge from quantum processes, we are participating in the very phenomenon we seek to understand. The quantum realm invites us to embrace mystery while pursuing understanding, to hold both scientific rigor and philosophical wonder, to recognize that the deepest truths about existence might be found not in choosing between mind and matter, between consciousness and cosmos, but in discovering how they dance together in the eternal quantum ballet that we call reality. So as you drift towards sleep tonight, remember that you carry within yourself the same quantum mysteries that govern the stars. Your dreams may be quantum computations, your thoughts quantum events, your very being a localized expression of the universe's infinite creative potential. In the gentle transition between waking and sleeping, between conscious observation and unconscious rest, you participate in the same phase transitions that quantum particles undergo as they shift between states of possibility and actuality. Sweet dreams, fellow quantum traveler. Here's a concluding paragraph for your video about quantum particles. And so, we drift to the end of our gentle journey through the quantum realm, where particles dance in superposition and reality becomes beautifully uncertain. We've seen how at the smallest scales, the universe operates not with the clockwork precision we might expect, but with a kind of cosmic improvisation where observation shapes reality and possibilities exist in harmonious suspension until the moment of measurement. Perhaps the most profound lesson from our quantum wanderings is that mystery isn't the absence of knowledge, but the presence of wonder, reminding us that even in our age of science and certainty, the universe still whispers its deepest secrets in the language of probability and dreams. Sleep well, knowing that you are made of these same quantum dancers, forever entangled with the cosmos in ways both invisible and profound.